welcome to the session. So in this particular video, we are going to start our new module of graph data structures, right? So we are talking about a very basic part in this particular session so that it will help you all to understand the upcoming portion that we want to discuss, right? So I hope you all are excited. Yes? So let's get started. So here, whenever we are talking about a graph-based data structure, the very first thing that you should understand is, again, it's a kind of a non-linear data structure, just like the trees we have studied, right? It is again a non-linear kind of a data structure, where the data or the nodes that you are storing is not present in a linear fashion, I would say. Okay, so it's a non-linear data structure. That is the first thing that we need to remember. Okay, fine. Now, whenever you will heard this term called as graph, you will listen two terms. One is called as, so graph is basically, I would say, composed of two things. One is called as edges, right? And another one is called as the vertices. So edges and the vertices are the, I would say, two components of a graph. Now you can ask me one simple question, that the similar kind of thing, that is the edges or the vertices are also known as the nodes, right? The same thing I have talked about when I was covering up the introductory part of trees. Then what is the difference between the trees and the graphs? Very good question, which can be asked from you as well. So whenever we are talking about the trees, whenever we are talking about the tree-based data structure, there is a much similarity, I will say yes, because it's also non-linear, it's also having the edges and the nodes. The major difference that you should know between the tree and graph is that tree does not form a cycle, And that's why I would say tree is always a directed graph, I would say. But when we talk about a graph can easily form up a cycle. And that's why it is either, you can say, undirected, or it can be a directed one. It can be a undirected or it can be a directed one. Both of them are there here. So this is the major difference, I would say, between the trees and the graphs. What are the applications where we are using graph? Any idea in real life? Any clue? We are using it maximum, whatever you are using nowadays, we are using there. Still no idea? Let me tell you. So in social media, I know everyone has their Insta ID. Everyone is having their LinkedIn ID. Everyone is having their Facebook ID, right? So whenever you used to post something, and if you will observe, for example, I posted one article or I posted one passage on my LinkedIn. Now suppose you liked it. You liked that article. What will happen? Your followers will also able to now see my article in a top-notch page. How is that happening? So always remember that whatsoever Insta post, whatsoever I would say LinkedIn post, or any kind of a social media, whichever we are using, graph plays a very important role in terms of maintaining a relationship, right? What will happen, for example, if you will just like my post, or if you will be adding in my friend circle, so there will always a edge which will be created between me and you. For example, I am Priya and there is some other person, suppose Ram. So he sent me the request, or in a way, yeah, you can say he sent me the request and I accepted his request on LinkedIn. So now we both are connected. So how this connection will happen? So me as a node, he as a node, and there is a edge which will exist between us. Now, apart from that, you will observe the other difference between the graph and the tree is on the basis of the traversal algorithms. In graph, you will study that we will be having majorly two important traversal algorithms. So in graph, we will be having two traversal algorithms. One is called as depth first search. One is called as depth first search. And another one is called as BFT, called as breadth first search. Breadth first search or traversal, you can say. In tree, we already have covered up the traversal algorithm so far. That is, we have three different traversal algorithms. One is pre-order, one is post-order, and the last but not the least is in order, right? So these are the three major traversal algorithms in trees that we have, correct? Okay, so now we will be able to get an idea what is graph, basic idea, what is the difference between the tree and the graph, and what is the major application of the graph-based data structure, right? So basically, in order to build any networking, for example, in any of the social media platform, we are using this data structure a lot, right? Social media platforms. Okay. If you will observe on LinkedIn, those who are having maximum followers, the number of impressions to that article or the reach of like or different kinds of emoticons that we have is quite high as comparable to the one which is having a lower followers. Why is that so? Because the person who is having the more followers, they will be having more edges, more connections, more networks towards other people. That is what you can say. So again, networking wherever graph is the one which is playing a very critical role there. Okay, fine. Now, how many different types of graphs that we have? How many different types of graphs that we have? So, usually speaking, we will be having two types which I want to discuss here. One is called as simple graph. Simple graph. And another one is known as multi-graph. Multi-graph. So when we are talking about simple graph, in this particular graph, we are not having no loops. So this will not allow any kind of a loop. Okay. Whereas in multi-graph, loops are allowed. Loops are allowed. That's why I was saying that in a graph, there exists a cycle. So you will observe in multi-graph, there are a lot of cycles which are there, right? Okay, so this is the major difference between the simple graph and the multi-graph. Let me talk about one more term. If someone is not aware, please see this also very much carefully. If suppose someone is asking to you, what is the degree of a node? What is the degree of this particular vertex? So, for example, I will create one graph here, 1, 2, 3, and 4. So there exists an edge between each and every node that I have from 1 to 2, from 1 to 3, from 3 to 4, from 2 to 4, right? There exists a proper edge between each and every vertex. From 1 to 4 again is there, and from 3 to 2 is there. Now here if you will observe, am I using any loop? No, not yet. So this is an example of, I would say, a simple graph. This is an example of a simple graph, and because I am not applying any kind of directions here, that's why you can say that this is a undirected graph as well. This is a undirected graph as well. So this is a simple graph as well as undirected graph. Now if suppose someone is asking to you, what is the degree of the nodes that you have in this particular graph? Degree of all the nodes or the vertices that you have. What you will say? What do we mean by degree? That how many edges are attached to each and every node. For example, if I will talk about the node number 1, how many edges are there? 1, 2, and 3. These 3 edges are attached to node number 1. So it will be 3. For node number 2, again 1, 2, and 3. For node number 4, again 1, 2, and 3. For node number 3, it is 1, 2, and 3. Means the degree of all the nodes that I have will be equal to 3. So what do we mean by degree? That how many nodes, how many, I would say, edges are connected to each node. Edges are connected to each node, right? This is what is the degree meaning. Okay, this is what we got, right? So in this particular case, we will be having for each and every node the degree as 3. If you will observe, this degree is, can I say it will be equals to n minus 1 in other words? Where n is indicating the number of nodes that I have in this particular graph. So here what I am saying is that if you will observe, degree of all the nodes will be equals to 3, which is nothing but is equals to 4 minus 1. So what I am saying is that in a simple graph, the maximum degree that you will be able to get for every node will be equals to n minus 1. And the minimum degree is 0. What is the meaning of 0? For example, this is a node. Now this node is not having any further node which is connected to it. Then the degree will be 0. Right? In this particular example, if someone is asking to you, what is the degree? So you will say it will be equals to 0. Right? So this way we will be able to get the minimum degree and the maximum degree for a simple graph. Now, listen this carefully. If I will add one more edge on top of this graph, the graph which I have just now showing to you. For example, what I will do, here I will be having 1, 2, followed by, I will say 3 and 4, right? This is a graph which we were talking about. Now, in this graph, I am having a maximum degree with respect to a simple graph. If suppose I will add one more edge on top of that, anywhere, suppose like this, or maybe like this, then this will become something called as multi-graph. Multi-graph. Why? Because in multi-graph, first of all, this kind of a self loops will be allowed. The very first thing, self loops are allowed. Moreover, this kind of parallel edges, this is called as parallel edges. So there is already an edge, and parallel to that we have created one more edge. So the parallel edges are also allowed. Parallel edges are also allowed. So self loops are allowed, moreover parallel edges are also allowed here. So this is the simple meaning of I would say multi-graph. So the graph which is having a maximum number of nodes in a simple graph is also known as what we called as complete graph. Complete graph. Why complete? Because it is having a maximum degree. Whereas the graph which is not having any of the degree will be 0. For example, this is also a graph. Listen, this is also a graph. For example, here this is the data that I have. Now here if I will talk about the degree, what is the degree of A? So you can say that degree of A is something which is equals to 0. Here also if I will talk about what is the degree of B, you will say to me that again it will be equals to 0. If I will say that what is the degree of C, you will again say to me it will be equals to 0. And for degree of D also, you will say to me that it is equals to 0. The graph for which all the nodes have degree 0 is known as what I would say null graph. So these are the different types of graphs which I want you guys to be aware of. So complete graph is having the maximum degree of every node. Maximum degree is there for each and every node. Always remember, here I am talking about maximum degree for each node. And here if you will observe, for every node we will be having a degree of 3, which is maximum, which is n minus 1. Right? But when you have the minimum degree, which is equal to 0, this is known as the null graph. So until so far what we have covered up, in a nutshell, we have seen that what is the, first of all, meaning of a graph, what are the applications of that, including the types. We have seen what is simple graph first. In simple graph, we have two different components or the names, followed by null graph and the complete graph. Null graph and the complete graph. Right? This is fine. Apart from that, we also did a discussion of what do we mean by multi-graph. Fine. Apart from that, we also have discussed that the maximum degree in case of a simple graph specifically is n minus 1, and the minimum degree that we have is equals to 0. Perfect. So when all the nodes have the degree 0, which is the minimum degree, then it is null. When all the nodes have the degree n minus 1, then it is called as a complete graph. Perfect. Right? So far so good, I hope. Now let's move ahead and talk a little bit about the properties of the complete graph that we have. So let's talk about very important properties of the complete graph, which will be helpful for us to understand the upcoming part of our session. At least we will not face any difficulty if we know all these things. Right? So what are the properties of a complete graph? Let me again try to create that same graph which I was showing to you in the above part. So this is the graph that we have. 1, this is 2, this is 3, and this is 4. This is the graph that we have. Perfect. Now in this particular graph, every node has its maximum degree. That is fine. Now, if I will talk about how many total number of edges, that I have in this complete graph. So let me count 1, 2, 3, 4, 5 and 6. So can I say that it will be equals to 6? The total number of edges will be something which is equals to 6. How it is coming out to be 6? The formula to calculate the number of edges in a complete graph will be n into n minus 1 divided by 2. N into n minus 1 divided by 2. Where n is nothing, so wherever I am using n, please, I will not write it again and again. N indicates the number of vertices, or I will say it as the number of nodes. Fine. So here it will be, how many number of nodes that we have in this case? It will be 4. So it will be equals to 4 multiply 4 minus 1 is 3 into 2. So it will be equals to 2 to the 4. So it will be equals to 6. And that's where 6 is coming into picture. By the way, what is n into n minus 1? What is n into n minus 1? So let me talk about one more question from you before talking about that thing. What is the sum of degree here? Sum of degree of each and every node. So if you remember, we have already discussed that for every node we will be having degree 3 and we will be having 4 number of nodes. So can I say that the sum of the node is 4 into 3, where 4 is the total number of nodes that I have and 3 is the degree of each node? Degree of each node. So can we say that the sum of the degree will be something equals to 12 here? Right? So what we are doing here, we are saying that it is nothing but is equals to n into n minus 1. because n is the number of nodes and n minus 1 is the degree of each and every node, right? So what I'm saying is that in this formula, if you will see, the numerator part indicates in a way the sum of degrees. The sum of degrees. So if suppose someone is asking to you, can you tell me the sum of the degrees? You can instantly tell now. Why? Because now you know that, now remember this thing, that we are talking about complete graphs only. So whatever properties I am discussing here will be valid only for the complete graph. So how you can easily calculate the sum of degree? Because now you know the formula that the total number of edges is something which is equals to the sum of degree that we have, divided by the value of 2. So if I want to calculate what is sum of degree here, so sum of degree is something which is equals to how many total number of edges that we have, multiplied with a 2. So this is the way, or I would say another way to calculate the formula of the sum of degree. That's why, or it can also be written as 2 times E, where capital E is indicating the number of edges. I will use this particular formula later on. So at that point of time, please don't show me the picture like I don't know how it is happening, right? We already have proved this stuff and I have shown you everything in front of you in this session. So that's why I would say that basics or the fundamental session or the introductory session of each and every module is very much important, because there I am talking about a new terms which I will use in the next upcoming part of my videos, right? Okay, so this part is pretty much fine. Now I want to discuss about the relationship between the number of edges that we have, and the number of vertices that we have. Let's talk about the relationship between these two, right? Okay, so again, all the aspects which I am talking about here is only for the complete graph, because we will use a complete graph a lot. That's why we are talking an in-depth discussion of that. We just now studied that the number of edges is equals to, can I write like this? V into V minus 1 by 2. Same thing. V or N is same only. So here what I can say is that the value of 2E is equals to V square minus V. Can we write like this? Right? So here we will be able to get the relationship between the number of edges and the number of the vertices. So in terms of big O time complexity, can I write that the edges is something which is equals to big O of V square? Big O of V square. Can we write like this? So this is one thing. So this is the thing that we already know. From there, we get to know that the edges can be written in terms of approximations as V square. Okay, if I will take log on both sides by taking, I would say, log on both sides in above equation. So what we will be able to get? We will be able to get the value as log of E, which is equals to 2 times log of V. Can we write like this? 2 as a coefficient will come up front here. So here if you will observe, what I can say is that the log of E value can also be written as big O of log of V. This is another important thing that I am talking about here. So this derivation is also pretty much helpful in the upcoming part of our classes, which you will observe. That's why I am talking about this relationship as well. Again, wherever log E is written, if I am replacing with a log V, don't get afraid that how is this happening. This is happening because we already completed with the intuition behind that, right? So again, this part is valid only when I will be talking about something called as complete graph, not in other graphs, because in the complete graph only this particular relationship holds true, not for the other kind of graphs that we have, right? I hope that whatsoever basics I want to cover up in this part of the session, I have completed. If you still have any sort of doubt, do let me know for sure. I will for sure try to resolve it as soon as possible. With this, happy learning to all. Bye-bye everyone. And I'll see you all in my next upcoming video.